Hey folks, so this is me working through example 7 from your section 6.1 notes. We're going to prove the following theorem. If W is a subspace of Rn, we want to prove that W perp is also a subspace of Rn. Okay, so let's see what we can do here. So the strategy is to use the 3 axioms of subspace, right? So first, I want to show that the 0 vector is in W perp. So how do I do that? Well, what I need to do is say that 0 is orthogonal to everything in capital W. Well, that's actually not too bad. So if W is any vector from the original subspace W, then of course 0 dotted with anything is always equal to 0. So the vector 0 is in the orthogonal complement, right? I mean, the orthogonal complement by definition is anything that's orthogonal to everything in W, and the 0 vector is, right? Just because it dot products at 0. So the first part is not too bad. Second, let's show that if, let's say, let's call it U and V are in W perp, then their sum must also be in W perp. Okay, so for this one, well, let's say that, if U and V are in W perp, what that means is U dotted with W equals 0 and V dotted with W equals 0 for any W from the original space W. So what I want to show is that U plus V also dots to 0 with any W and W. Well, this is something that I actually know how to compute because of the properties of dot products, right? So U plus V dotted with any W, because I know the dot product is distributive, this equals U dotted with W plus V dotted with W. But from our above assumptions, that's 0 plus 0, which is still 0. Thus, U plus V is also orthogonal to everything in W, and thus is in W perpendicular. Okay, last part. We want to show that if U is in W perp and C is a real number, then CU is also in W perp, a closure under scalar multiplication. So again, we sort of use the same structure. If U is in W perp, that would mean that U dotted with W equals 0 for any W in capital W. So now if I want to check why is it still the case that C times U satisfies the same equation, well, again, this is properties of dot products. CU dotted with W would be, again, using the properties of dot product, I can pull out scalars. This is C times U dot W, which is C times 0, which is just 0. So again, properties of dot products tell us that C times U is still in W perp. Okay. So we conclude W perp is indeed a subspace. It satisfies all 3 axioms of closure. Well, we have the 0 vector in there, and we have 2 closure axioms. And that's it. So short and sweet. If you have any questions about how this proof worked, how the ideas came about, let me know. And otherwise, I'll see you in class.